Cesar, how are you? Welcome to the Starting Pixel podcast. You are number 20.
Really? That's
Yes.
amazing. Thank you very much, Rob, for having me. That's amazing.
Right. So very pleased that we've been able to get to 20 and I think we've got guests booked until November, which is pretty awesome. And people are waiting quite a long time.
That is amazing. And I saw a few of the podcasts, and definitely there is very, very interesting conversations being in there.
Yeah. It's quite, it's an interesting area, that's for sure. Anyway, onwards with the show. First of all, tell us a little bit about you then.
Well, my name is Cesar. I work as a product lead for Brompton Technology, but I have been forever in this industry. I love what we do. I think that we are very, very lucky as a community. That's why I really like Starting Pixel. I really like what we create as a group usually in this industry, because being in the intersection between technology and creativity, there is not many people that is lucky enough to be there. So I love what we do. I have been working a little bit of everywhere. I started from the very bottom doing crew job. I have been sound engineer. Not many people know that, but keep it quiet between you and I. And then I got into video and I loved it. I thought that video is always growing, is always evolving. It keeps you going and learning and interested.
Well, so tell us a little bit about that side of things then. So when you say you got into video, was that the crew side? Because you're obviously Brompton, and I've sort of looked at your background. You've worked for Disguise as well, and Brompton before that, if I remember rightly, which is very sort of it's an engineering focused side of LED balls and processing, right? But so were you in the crew? How did that work? How did you fall in love with it?
Well, I mean, obviously everything comes from somewhere else. I actually studied electronics. That was my first degree in Spain. To be completely honest, I hated it. I didn't have a real reason to study electronics. I remember my last year project was to create the programming for a washing machine. So definitely not my highest motivation. When I finished with that, I went into sound engineering. I was passionate about working in a recording studio. But for anyone that is listening and that is starting and that is passionate, sometimes when you achieve your dream of when you are 15 years old, it turns out to be the most boring job in the world. And that's what happened to me. And I felt a bit confused. And I was in London. For me, to get into the industry, I didn't know anyone. I came alone. I didn't have any English. So I had to work from the very bottom. And that's why I did a lot of crew job. I wanted to do something that was related with the industry, with the music. And so I started doing crew job. Obviously, the UK is an incredible place to talk about live events. Live events are massive. But where the real money is in all these industries, and for all the freelancers in there, they all know that, is in corporate jobs. So doing corporate, I was doing both sound, and because they want to save a little bit of money, you do a little bit of video as well. For the smaller jobs, they get one person doing both things. So I started doing both things. And after a few years, this is when I got into Brompton. So I started in Brompton. I was sorry, go ahead.
So when you were sort of talking about it, you're sort of, and correct me if I'm wrong, you're thinking about that sort of corporate events. Is that right? So you're crewing corporate events, and you're making sure you were one of those people sitting at the back, making sure all the microphones are working, and actually someone's pushed the record button. Yeah, gotcha.
So many lapels. Yes,
been there.
And that's the thing. And this is how I got a little bit into video, but it was very, very basic, like really nothing that interesting, a bit of projection. But then I got into Brompton. And to be completely honest, when I started in Brompton, I had no idea of what LED processing was. But I knew that there was a technology that seemed very interesting. And that's when I got into video. I realized that, so I ended up working for Brompton, and I realized that video had so much potential. Everything is growing. There is so many new applications happening to LEDs. And after a few years, this guy was coming up, and he was the coolest kid in the building. And I thought, like, wow, I want to do that. I want to learn about media servers. So I was very, very lucky to get to work in these guys. And that was, it was a roller coaster.
When you were the first time you were at Brompton, so was that a lot of that to do with the use of video walls at corporate events? So they'd be playing videos?
No, the first time I was in Brompton, actually, it was technical support. Brompton is a manufacturer, right? So it was very much of the machines that are being developed and supporting our customers.
It's broken. What do I do?
So it was definitely that. It was the machine is broken,
Got
or
you.
not even that. It wasn't that much about broken, or I don't know how to do this thing. And I don't know.
Right.
It was as a freelance, being in the other side, helping other freelance that are panicking, because their
Right.
show is going wrong,
Yeah.
was actually quite rewarding.
Yeah, I
Being
bet.
able to help these people. Exactly.
Got you. Nice.
But yeah, but then I went to these guys. I was doing the same technical support, but these guys is obviously a company that tackles many, many industries at the same time. For better or for worse, after half a year to a year, I moved to Hong Kong to help the teams in APAC, but COVID happened. And as we all know, it was a very, very interesting time. And that changed, for me, that changed everything. Suddenly, you have virtual production exploding everywhere, so many new technologies coming into the world of media servers. Suddenly, there is a media server that is receiving information from cameras, is receiving information from trackers, is receiving information from everywhere. And that's how I got very much into the world of virtual production. It
So when
was
did you have any before that happened, did you have much visibility of the use of people using LED processing and the walls themselves for filmmaking, or was it
So I mean, before these guys, I did have some visibility of projects like The Mandalorian. When I was still in Brompton, The Mandalorian was starting to happen. But it was something so niche, so strange that a few people was doing in a studio in Hollywood. And actually, when I started in these guys, they were developing the whole XR technology. And I'm going to be completely honest with you. If someone from these guys hears me, is the first time that I actually talk about this. The first time I saw it, I thought like, nobody's ever going to buy this. It
yeah,
does not look good.
right.
Right? I thought like, this is so behind that it's going to take forever to properly develop it. But, things changed very, very
Right.
quickly.
Right. So there's nothing like a pandemic to speed things up, right?
Yes,
Right.
exactly.
It's amazing what how the when necessity bites, I guess, is that's when lots and lots of, as you say, sort of engineers and technologists all sort of came together kind of thing. It was mad time.
Yes, absolutely. I mean, and there was, for me, I mean, I understand there was a lot of complications for many freelancers. People was suffering with their jobs and all that. But at the same time, there was an amazing community of people working together and pushing and working really, really hard to do a technology that was back then very, very difficult. Still is not extremely easy. The tools have been developed to make it a little bit more, but it was an amazing time.
Yeah, it was a hack, wasn't it? Really, I mean, it literally was.
Initially, it was a hack, definitely. How can we make a tracker change the point of view of a camera and let's use LEDs for this? Cameras and LEDs never really worked together very well, but how can we synchronize them together? All these kind of things were a big part of it.
Yeah, yeah, cool. So then you were so that was it's hard to believe that was like 5 years ago, right? It's like which as I sort of I've always said like virtual production is a bit like a 5 year overnight success. At one point it will be successful and everyone go, oh yeah, it's been around for ages. But it's also just yeah, 5 years ago, just you could measure it in months, really, kind of thing. It really
Absolutely.
wasn't that long ago. But it also feels like it
Absolutely.
was absolutely years and years and years ago as well.
Yeah, it was a very fast time where everybody was working really hard. Everybody was studying really, really hard as well. I mean,
Right.
I don't
Yeah.
think that there was anyone with all the skills that you require to do virtual production. I mean, knowing about LEDs and color workflows and all this, knowing about Unreal, knowing about trackers, knowing about media server, cameras, lighting, all that is a lot.
Right. And that they work together seamlessly, which of course was never really that was always a challenge as well. So
Exactly.
you're in Asia at that time. Of
Mhm.
course, that was the thing. And then what happened? Did you stay there or did you move around?
So after this, guys, when things calmed down a little bit, I decided that probably was a good time to move on into actually driving a studio. I mean, I spent so much time working with studios day in, day out, putting 16 hours a day to make sure that they are working, that I thought like would be amazing to actually focus in one and, and develop it and make the best quality possible for international standards here in Asia, in Hong Kong in that time. So I started working with a studio called Motion. Again, amazing experience. we built the studio basically from scratch, and we trained a team and all these things that wanted to bring some knowledge that was a little bit lacking in the region. So I did that, but again, after a few months, I realized that the production wasn't really for me. I am an engineer and I like building stuff and putting systems together. And once it is put together, the whole cinematic part of it, I wasn't that passionate about it. So I got a great opportunity with Brompton, and here I am again.
Back at Brompton. But and are you
Back
so
at Brompton.
and you're and what's your role at the moment then? Is that
So it is product lead. That basically doesn't really mean anything, to be completely honest. But what I do is using all the experience that I had during all these years that I was in the middle, I am bringing it to Brompton for internally and for external partners and customers and all this. Give them the best workflows so they can achieve whatever they want to achieve with their systems.
guy?
Because the fact is that working in building studios and working in these guys doing all these virtual production experiences and all this, you work with so much equipment that what my specialty became was a put system together and optimize it for a customer's requirements. And now what I'm doing is within Brompton, I wouldn't be able to do this job if I didn't believe that Brompton is the tool that is going to give, in most cases,
Got you.
all the benefits that the customers are looking for.
And these customers, they're not just virtual production. I'm assuming it's like anyone who needs the solution.
Absolutely.
Got you.
Absolutely. It will be
Brilliant.
for anyone, installations, live event, broadcast, simulation, whatever industry it is. But I believe that virtual production is so complex and it requires so many tools. And so as well, if we are talking about quality of video, cinematographers, they have an amazing eye for quality, right? So it is very difficult to find someone else in a different industry that is going to require something higher in terms of quality of video. So that gives me the tools to actually, work with all these people.
Yeah, and yeah, which is a great position to be for sure. So that's really cool. So and I think we can. I mean, we've sort of connected years ago now. Actually, I think it is. I can't remember how, but anyway. But
Time flies.
but yeah, no. Then there was a conversation I think on the WhatsApp group about sync and GenLock, which is probably the bane of most people's lives kind of thing. And it's the one. And actually, I'm going to let you explain it. And I'm going to play it back to you. So I'm going to be the voice of the non-technical person.
Mm-hmm.
What we thought we'd talk about on this podcast anyway is just your experience across your career. So not just working for Brompton at Disguise and your other experiences as well. So explain quickly in your words what that is. What is the difference? What is GenLock? What is synchronization? Why is it important?
Yes, absolutely. So that is how the conversation started. As I said, one of my passions is to make sure that people have all the tools they need for a system, right? To achieve what they want to achieve. In Brompton, and I don't want to get too much into the brand and so on, but in Brompton, one of the things that we specialize on is in making things that can be quite complex much simpler. And one of these things is synchronization. That's why a lot of people might not realize really what is happening in the background. But just to put it very quickly, synchronization has many, many levels. You have the basic synchronization. That is what people call GenLock. GenLock is a very, it's just a signal. It's just a pulse that you send to different machines so they all know when to do something, right? But it doesn't tell you when or if it is this pulse or the next one. It's basically like a drum, just making a beat, right?
Cool. So let me just quickly play that back to you in Rob's words. So you've got different bits of equipment, right? So typically on a film set, let's talk about that. But that and that could be cameras, it could be the LED wall, it could be some technical processing, I guess, that going on. And there might be some other ancillary technology as well, where you talk about synchronization, and GenLock's one of them. They all know when to do something. And that can be, it's not like a moment in time, it's a constant knowing how to do something, right? As you say, it's like a drum beat.
Exactly.
And that drum beat could be 24 frames a second. But it could also be 120 frames a second. Does that sound about right?
Yeah, it is exactly that. And
right.
Yes, you could have, every single device, like the LED processor or the media server or the cameras, they will have their own clock. But these clocks being electronic devices, all of us that lived with watches before the internet, we know that clocks don't go all at the same speed.
Right.
Right.
Yeah.
It is more or less the same, but it's not the same.
It's the same. Okay, so that's that. So what? But why is it important? Actually, that's the
So it is very important because the system need to work at the same speed in order to affect different things in the same. For example, if you are capturing with your camera, you are capturing the LED, you want to see one frame and capture that frame at the same time. Because if you have two different timings, you will be capturing 1 or 1.5 or 1 3/4, and
got
this
you.
might be changing over time.
So you say your camera's running at 24 frames a second, and your LED panel is displaying 24 frames a second. When the shutter of the camera opens, it needs to see the entire image every 24th of a second. Otherwise, if it wasn't, it would be in between, which could be half of the next frame and half of the previous frame, and you'd have that. And this is, I'm sure it's not as blunt as this, but you'd have that sort of wavy line, or you'd have something that doesn't look right.
Exactly.
Is that right? Yeah.
Exactly.
So basically,
Absolutely. That is
opens,
exactly it.
they're literally doing this kind of thing. Right, got you. Okay. And without that, it wouldn't see the same thing. And obviously, in a very expensive film, you need to see the thing.
Absolutely. That is exactly it. Not only you wouldn't see the same thing, that thing might be changing over time because they are working at different speed.
Got you as well. So you might have them, they might be sort of okay, but then this one does this sort of this, and then suddenly you've got this. Yeah, so at 20, if they're out of step, you've not got 24 frames a second, you've got 48 frames a second. Because it's
exactly.
right kind of thing. Right, okay, got you. I think that makes sense.
Now, is have one thing to consider, that is that even if everything is going at the same speed, you might be capturing the middle between two frames every single time, right? Because not we are not synchronizing that everything starts at the same time. We're just saying that they go at the same speed. So for that, there is another tool that is the next step that will be frame offset. So phase offset, sorry. So you take the phase of that frame and you make sure that it is exactly on the same position as the camera is opening and closing. So you get the full frame as you were describing before.
Yeah, because it obviously goes, and this is me being incredibly naive, and it obviously has to go from one frame, and then that frame has to disappear somehow, and the next frame comes in, and it has to be fully loaded. However that loads, whether or not it suddenly appears or it builds up, or however, it has to be fully loaded. And you call that phase offset?
Yes, exactly.
That's the phase offset. Okay. And then as soon as it's loaded, then that allows the camera to see it, to open its sensor.
Exactly.
It sees it at a moment and it closes before it starts to rebuild the next frame. Got you.
That is exactly it. Yeah.
Gotcha.
And this is the basics, right? Now things get a lot more complicated. Why? Actually, the way we display frames in an LED is, and anyone that ever worked with LEDs will realize that frames work at a much higher refresh rate. It works at 1900 or 3400 or 7600. There is many refresh rates that are much higher than what we are used to that for video, that, as you said, can be 24, 25, 30, 59, 60. And what is happening is that, for reasons that I don't want to get into, but this is how LED panels work, what they are doing is they are blinking really, really fast. And depending on how bright they are, they blink for longer or for shorter, but they are basically blinking.
So actually, that's a really, really good point. Let's just quickly explain what an LED panel is and a volume, right? Because there's going to be people who listen to this, hopefully, who go, okay, they're imagining it's one big thing, right? It's like a big TV screen, which just comes out of a big box. It's not quite that, is it?
Yes, exactly. So an LED panel is basically an array of pixels. So very little small lights that will be able to represent many colors, because, well, they can represent many colors, but you have them in an array depending on the pixel pitch, depending on the size of the panel, etc. They can be closer or they can be more separated.
So a pixel pitch is basically the distance between each pixel, right? And the smaller the pixel pitch, the finer it is. And these things, even at 1 millimeter, if you were looking at it like here, you can see them, but 10 meters away, you're never going to see that pixel. Exactly.
And for these people in London, I love the fact that Places like the BT Tower, for example, it has a massive pixel pitch. Or the Sphere in Las Vegas, the pixel pitch is massive. It's really, really big. But because we are so far looking at it, nobody sees it.
Right. And then each of those panels is about how big?
So the most common standard is a 50 by 50 centimeters.
Right. So that would be 4 to 1 square meter. Yeah.
Yes,
Yeah.
exactly.
Yeah. Yeah. And give us a bit of an idea how much they cost a range per.
I mean, there is panels like you have very, very cheap panels. Sadly, like everything in this industry,
Right.
you get what you pay for.
Right. Yeah. So just to give people an idea of sort of how much an average cost one.
So it will range all the way from 1,000 USD per panel to 9,000 USD per panel.
Per panel. So
and then you have a complete range.
I'm going to say that out loud. So that's $1,000 per panel, and you need 4 per meter. So that's £4,000 per square meter, which is about the size of a very large TV screen. Yeah. So that's that's the sort of lower end. And you said about £8,000 a panel. So that's 16. So that's $32,000. Sorry, for something the size of a very large television that you could buy from your local electronics. Yeah. So that's just okay.
And people build very, very large TVs.
Right. And they build very, very large TVs, right? If anyone's been to a live event like Adele or the Rolling Stones or somewhere like that, or Rolling Stones or anything like that, they are very, very large TVs. Yeah, cool. Okay.
Exactly. Yeah.
Cool.
So, and then as I was saying, the reason why the prices go like this, because it's not a cheap device. It is mainly because they have an incredible amount of technology and components inside. It is a lot of pixels that have to be driven by many, many driver ICs. So that's why the prices go like this.
Yeah. So just because I'm a geek, right? So on a single panel, what's the sort of average pixel picture that's used these days?
It depends on how big it is, but I mean, it's a very interesting industry, as I said. A few years ago, I remember when I started in Brompton, 3 point something was a crazy fine pixel pitch. And that was by the end of it, by 2019. Then we got into the 2 point somethings. So the 2020s, the beginning of the 2020s was 2 point something. And now it's very common to see a 1.5 type of panel.
So if we said 2 millimeters as just as a thing in the air, so 2 millimeters across a 500 millimeter panel, that's 250 LEDs wide by 250. 250 squared is a lot. 250 squared is going to be like
62,000
just for one panel, right? And that's why they're expensive. And that's just one. There's only 4 of, and then you times that by 4 to just get the meter. How many in a meter? So that's 62. That's 60. I don't know. That's a lot. And then
it's 240, 250.
Yeah, and then that's just 1 square meter. And then
that's. Yeah.
So we're talking, we're talking millions of pixels on on a standard LED volume you'd use for virtual production, and they've all got to blink at the same time, right? And to your point, dumbing it down, they all have to blink at the same time.
What is the problem? They don't blink at the same time.
Right.
A big part of it is that, and this is where the whole synchronization thing happened. Anyone that ever bought a panel, they heard the term scan multiplexing. Basically, what you do is, because if you have 62,000 pixels in one panel and you want to drive them all at the same time, you have to put 62,000 IC drivers in the same panel. There is the problems with this. IC drivers are expensive, or much more expensive. You don't have a space in a board to put 62,000 of them.
So you said an IC driver, yeah? Okay, and so that's the thing that makes the light blink, I'm assuming.
Exactly.
Right?
That is controlling the lights, yes.
So that's controlling the lights, right? Okay.
And this is where we get to the 8-to-1 or 6-to-1 or 12-to-1, 16-to-1. 16-to-1 was quite common a few years ago. The only thing the thing that is improving is not only the pixel pitch. The amount of drivers that you put is increasing, so you can have less pixels per driver, so it gives you better results because they blink at a more similar time. If you have 32 pixels being, or 32 lines of LEDs being driven by one IC driver, it will take longer to go back to the first line, right? Well,
Okay,
if that IC driver is driving 8 lines, it will be much faster.
got you. So let me play that back to you. So we've got a panel that's we've got 500 millimeters by 500 millimeters. They've got 250 lines. Let's use the 2 millimeter pixel pick. So 250 lines, and you need a driver to drive a set number of those lines. Just that driver does is does those, say 10. It's responsible for doing those top 10, and then there's another driver for each of those, and it takes time, right? When that driver, because it has to sort of try and control them. And what you're saying is that now there's more and more driver, or there's less lines per driver, so that's getting smaller. So that's more that's faster. Doesn't have to do so much work, but obviously then you've got a lot of drivers because you segment that down. And as the pixel pitch goes from, say, it was 4 millimeters last year, that's twice as many lines. You need twice as many drivers in that as well. And of course, then there's power and there's control and all that kind of stuff. Okay, got you. Okay.
Exactly. So basically, this is what we are synchronizing, right? And this is where the synchronization continues. All these actually have a meaning. Okay, guys, I'm sorry for the diversion into a very technical part of panels.
No, it's cool.
But we have to understand a little bit in order to know why things happen in the camera.
Yeah, no, absolutely no. Yeah, so we've got all of that going on in the LED walls, and then we won't even talk about color actually, because we can talk about that another day.
Yeah, I mean, there's many things.
There's many things. Okay, so that's sort of an explanation of the panel. Brilliant. Okay, carry on.
And then we have that, right? So we have pixels that are blinking, and what we are actually synchronizing so far is just frames. Now, because as I said, there are different lines that are being refreshed at different times. If you imagine that you open your shutter, let's forget about the synchronization of the frame. Let's just think about lines being refreshed, right? But if you open your shutter and you close it, and the top 4 lines have been refreshed or have been captured by the shutter more times than the bottom 4 lines, and this keeps repeating, suddenly, because the top ones have been captured more times, will look brighter in camera. And this is where all this horizontal banding starts appearing.
Okay, so because obviously, yes. So just to go back a little bit, play that back, because obviously when you refresh them, are they turning off and then turning on again? Right, so they go through a cycle of full illumination. They literally like your living room like light fader, right, on the door, rather than you pushing it actually when you push it to turn it on, it still has to do that thing. But the slow motion is that you turn up your dimmer and it has to go from off to dim. It just doesn't, even if it's super quick, it has to still go. That's physics, right? It just doesn't appear.
Absolutely.
Right. Yeah. The only other way of doing that is to have it on constantly and then remove something. But even that takes time, right? Anyway, I digress. Gotcha. Okay, cool.
But in the case of a chip, actually, because let's put an 8-to-1 multiplexing, right? If the chip is controlling 8 lines, it can control 1 line at a time, meaning that 1 line will be on at any given time.
Right.
So
okay. So
if you actually take a picture fast enough, you will see just 1 line on.
Got you. So it does one, then it does the next. So does it turn one on, then turn the next one on, and then the one before it is still on?
It goes off.
It goes off. Right. Okay. So on, off, and then that just goes through the 8 in a cycle. Got you. Okay.
But if you do that at 2000 times per second, nobody notices.
Right.
And that's the thing. That's why there are more things that are important.
Got you. Yeah, but it's still, I'm a geek. I like to know these things. Cool. Okay. Right. That explains that bit.
Yeah, kind of. If you guys have questions, I mean, I'm always open to have any deeper conversations. I'm trying to simplify it as much as we can.
Yeah.
And cool. I don't know everything either. I will have to pass you to someone that actually has a deeper knowledge of how they are configuring this.
Anyway.
But that is the thing, right? So the synchronization goes much deeper than just where the frame is falling. It's how many lines are we capturing for every single shutter. Now, the LED processor knows that. The LED processor knows when each line is refreshing. But if we give them the camera information, it will be able to, to do its maths to make sure that the times are matching for every single frame at any refresh rate, depending on the capabilities of the panel itself.
Right. Got you. So they don't do it when you've got a camera using 24 frames a second. The panel's not rotating at 20. It isn't refreshing at 20. It's doing it at 2,400, say, for argument's sake, times a second, which is 1,000 times per one frame of the camera, kind of thing. Right. Got you.
Well, 1,000, yes, 100 times for one frame of the camera, but yes,
Yeah.
absolutely.
Right. Got you. Gotcha.
So there is a big mismatch. This changes as well with brightness. Depending on which brightness you have, it will be different. There is some other things that make it change because of the way the technology works. But as a basic understanding of why further synchronization of systems is important, I think that this is a good enough explanation.
Sure. Sorry, yeah.
And basically what we're saying is that you really need to consider on how systems work, because that goes for many more things, right? I mean, we could have a complete podcast. I mean, we could have a whole series of podcasts about pixel pitch and about color, as you were saying. I mean, color is the big science in this industry. So there is many other things that can be considered in order to ensure that you have the best experience. Yeah, and at the end, with virtual production specifically, you are trying to recreate the real world. That is extremely difficult. Recreating the real world is very, very difficult. And making that without artifacts, just so that you don't take your customer out of the experience of the content itself, is very important.
Yeah, for sure. Yeah. Cool. Okay. That explains that bit. So what else is important in that, in the synchronization world of virtual production?
So, I mean, it is mainly, there will be a deeper technical things that you can do. But because of the way the panels work. And this is all coming from the fact that actually LED panels and cameras are not made to work together. And
No.
I should have started with that. The way the technologies are working is, it's not compatible because you have to synchronize things that are working at different speeds by default. But we are developing technologies. And that's why for me, where we are now with virtual production is so important, because we have all been suffering for quite a few years. We talk about virtual production in 2021 like it was fun, but I don't think that it was out of fun for many of us. Now we just have the memories. We reminisce about these times. But
I'm
back
sure.
in those days, I remember working 20 hours a day just because, you have a little bit of color that is not the playing game, or as I said, the refresh rates of the panel weren't good enough, and you don't understand really how to fix these things.
Yeah. Don't breathe, anyone. That was the thing. You got it working. It's like, no one breathe.
Exactly.
No one breathe. It's
Exactly.
working. Yeah, that was the thing. So also, actually, tell us a little bit about. So you sort of talking about that sort of GenLock and synchronization. Just very briefly explain what the pipeline is between the camera, or what is going on between that. So you've got this thing firing, it's all working, but and all you need to do as a cinematographer, and correct me if I'm wrong, is obviously light it all as you normally would do, but it's just like the real world. You push the record button, or someone pushes the record button on the camera, action, and it all sort of works. But there's other stuff that's going on. What else helps drive all of that?
Absolutely. In terms of, if we just focus in synchronization, one of the most important things, and I feel like, I have been working for manufacturers for quite a few years, and we sometimes focus so much in technology, but the fact is that technology should be just a tool so directors can do their job without thinking about it, right? The synchronization, what it is that. So you put your GenLock to make sure that every device is put together. We didn't talk really about how cameras work and how synchronization of camera works, but we could get as well into the difference between global cameras and rolling shutter cameras and how they are actually capturing content. Because a rolling shutter camera is as well capturing line by line, exactly the same way as a panel is writing by line,
Right.
but at a completely different speed. So considering that as well is very important. For example, a rolling shutter camera starts capturing line by line, but at some point, all the lines are capturing together. So how do you deal with these initial times in which the lines are starting to capture? How do you deal with the times when the lines are stopping to capture? You basically have to crop that and just focus in the time when everything is capturing at the same time. Now, the problem with that is that in this case, for example, of rolling shutter cameras, because they are reading line by line, and the panel as well is at a much faster speed, but still writing by line for the amount of pixels that are driven by one chip, no? But still by line rotating. If this is something that anyone that has been shooting has probably seen, when you start moving your camera, you will see some lines.
Right.
And there is nothing at all that anyone can do about it, because it is impossible to tell the camera where the panel is, what is the state of the pixels of the panel in that position. And that's why when you start going up and down, you will see some lines that then stop. Because as soon as you stop, you are capturing as well all these lines together because they are much faster.
Got you.
It is just this movement that is creating the issue. Now, if you do it slowly, you will not see it because the panel is really fast. How do you fix it? Low scan multiplexing, meaning that you have less pixels being driven by the same chip, higher refresh rates or scan refresh for the panels. The panels can do it faster. And this is
Right.
how we improve all these things.
So what are you up to at the moment? What's going on in your world?
Yeah, absolutely. Well, now we are here back in APAC. The thing is that, again, I love this industry. And one of the things that I love the most is developing territories. While in the US, in the UK, there is so many people that know what they are doing and they want to push and they want to grow.
Brilliant. Sounds really, really cool.
Yes, absolutely.
All
No,
right,
and
man.
this is the most important thing for me. I mean, I'm always happy for anyone that is listening to give more information. This is actually my job. I
Right.
am lucky
Brilliant.
enough that my job is sharing
Helping.
information.
Right. And you love it. And that's great.
I love it. Absolutely.
Right. That's all you need in a job. Goodbye, my
Yeah.
friend. Hopefully we'll see you soon.